This time, we are going to solve square root of 2 minus x equals x minus 2. Since the radical is already isolated at the left side of the equation, what we are going to do is we are going now to raise both sides by 2. So square root of 2 minus x raised to the power of 2 equals x minus 2 raised to the power of 2. Cancelling out, you have 2 minus x. After we cancel, what is left is 2 minus x equals the square of x minus 2. This one is a type of a special product. So, to square a binomial, we have to follow a certain rule. So, for example, we are going to square a plus b. The rule here is that we are going to square first the first term. Square the first term plus get twice the product of the first and the second term. So, a times b, get the product, then multiply it by 2. Then, square the last term. So, this is what we are going to do here when we square x minus 2. So, square the first term, which is x, that would be x squared. Then, multiply the first and the second term. X times negative 2 is negative 2x. Then, multiply it by a constant 2. So, negative 2x times 2 is negative 4x. Then, square the last term. Our last term is negative 2. Negative 2 times negative 2 is positive 4. So, here, what we're going to do is that we are going to combine like terms. So, since this is a quadratic equation, because the highest exponent of the variable x is 2, we are going to put all the terms on one side, then equate them to 0. So here, since x squared is already positive, I will not transpose these terms to the other side. Why? Because if I'm going to transpose x squared to the other side, it will become negative x squared. Then, we're going to divide both sides of the equation by a negative 1, or we're going to multiply both sides of the equation by a negative 1, so that x squared, negative x squared again will become x squared. So, it's a little bit hassle. But even if you do that, we would still come up with the same answer. So, here, I will just transpose 2 minus x to the right side. So, x squared, there is no other x squared. So, I'll copy negative 4x. X term, there is x here, which is negative x. Transpose to the other side, it will become positive x. Then, copy positive 4. Positive 2, when transposed to the other side, it will become negative 2. Then, equate all of them to 0. So, we are going to combine like terms now. So, 0 equals x squared, negative 4x plus x is negative 3x. Because negative 4 plus 1 is negative 3. Then, copy x. Positive 4 minus 2 is positive 2. This is just simple subtraction. I know you know that. So, here, the resulting equation is a simplified quadratic equation. So, what we are going to do now, we are going to find the values of x. But if the given equation is quadratic, remember, your teacher taught you how to find the values of x or how to solve a quadratic equation. You may have it through factoring, completing the square, or by using the quadratic formula. But since looking at the equation, this quadratic trinomial is factorable, I will just use factoring. Okay? So, here, 0 equals, I will make 2 parentheses, 2 pairs of parentheses. So, x squared minus 3x plus 2. Since this one is already 1x squared, that would be x here and x here, because x times x is x squared. Then, focus on the last term. You have positive 2. So, you have to look for two numbers such that when you multiply these two numbers, the product is positive 2. So, you have to, when you add these two numbers, the sum must be negative 3. So, here, you have positive 2. What are the factors of positive 2? It could be 2 times 1, the product is 2. When you add 2 plus 1, the sum is 3, which is not equal to the middle term. Okay? So I will try negative 2 times negative 1. That is also positive 2, correct? When I add negative 2 plus negative 1, the result is negative 3, which is actually the middle coefficient. So therefore, our factors will be x minus 2 and x minus 1. When we multiply this, the result would be x squared minus 3x plus 2. You can just use FOIL method. Okay? So, to find the values of x, I will make a T form. X minus 2 is equal to 0 and x minus 1 is equal to 0. Why do we have to equate each factor to 0? Because if x minus 2 is 0 times x minus 1, that is 0. Or if x minus 1 is equal to 0 times x minus 2, that is 0. It means that this factor might be 0 multiplied to another number, it results to 0. Or it could be that both of them are 0 because 0 times 0 is equal to 0. So finding the values of x, we have x equals positive 2 because negative 2 transpose the other side is positive 2. And x minus 1 equals 0, that would be x equals 1. Okay? So here, we have now the two values of x. Why is it 2? A while ago, we just had 1. It is because our equation is quadratic. The highest exponent is 2. So expect that you have two values of x. Okay? So even if we already have two values of x, we still have to do the checking. Why? Because it might be that one of them is an extraneous root. What do you mean by that? When we substitute 2 or 1 to the original equation, it might result to a false statement. So even if our solutions are correct, but when we substitute these values to the original equation, both sides are not equal. So you would consider that number that makes a false statement an extraneous root. Okay, so we will do the checking. So we have here x equals 2. So we will check them one by one. So x equals 2. Checking. Going back to the original equation, we have 2 minus x equals x minus 2. Substituting 2 to all the x's in our equation, we have square root of 2 minus x is 2 equals x is also 2 here minus 2. Is it really equal? Are they really equal? So square root of 2 minus 2 is square root of 0. Is it really equal to 2 minus 2? So 0, square root of 0 is 0. Equals 2 minus 2 is 0. Both sides are really equal. So it means it results to a true statement. Therefore, x equals 2 is a solution to our radical equation. Now, we will check also x equals, what's the other one? X equals 1. Going back again to the original equation, we have square root of 2 minus x equals x minus 2. So, square root of 2 minus substituting the values or the value of our x, which is 1, to all the x's, we have 2 minus 1 equals 1 minus 2. Are they really equal? Let's see. Square root of 2 minus 1 is 1. Is it really equal to 1 minus 2, which is negative 1? So square root of 1 is 1, which is, on the other side, is negative 1. 1 equals negative 1. Is it a true statement? They are not equal. Therefore, it results to a false statement. So, since 1 is not equal to negative 1, we consider x equals 1 as an extraneous root. This root may seem right when we solve it here, but when it is substituted to the original equation, it makes a false statement. So the only solution to our given radical equation is 2. X is equal to 2.